Hello everyone. In this video we're going to be comparing two numbers. We have 4 to the power square root of 2 and 3 to the power square root of 3. And we're going to try to find out which number is greater. Now, here's a question for you. Can I square 4 to the power square root of 2 to get 4 to the second power? And the answer is no, you can't do that. Okay, that's not going to work, because if you just square that, if you square 4 to the power root 2, you're just going to get 4 to the power 2 root 2, which is not actually very helpful. So we have to use a different approach. So here's what I want you to notice. So here's the plan. I'm going to show you how you can compare these two numbers, and then I'll give you the numerical values, and then we're going to look at it from a functional perspective. So that's the plan. Let's get started. So first of all, notice that 2 over 3 is 0.6 with the 6 repeating forever, right? And 2/3, because of this, is greater than 0.64. Again, this might come out of the blue, like, where did you come up with these numbers? How did you come up with them, right? You're going to see when I use them in my solution. Obviously, if you start with the solution and go back, it's easier to reverse and so on and so forth. But for those of you who are watching this for the first time, or who are seeing something like this for the first time, it kind of looks very different. I understand that, but take your time. Anyways, so hopefully we all understand that 2/3 is greater than 0.64. Notice that 0.64 is a perfect square, so I'm going to square root that for sure, right? Okay, so if you square root both sides, then you get the following. The square root of 2/3 is greater than square root of 0.64 because 2/3 is greater. So when you square root both sides, it's just going to be the same thing, all right, because it's an increasing function. But this is 0.8, which can also be written as 4/5. Wow, that is interesting. Why? Because this gives us something real cool. Now I know that square root of 2/3 is greater than 4/5. That is interesting. I could have find out, but I could just square root 2/3, but it would be harder. Notice that I didn't have to square root that. Okay. So now, how can I use this relationship? And notice that we are trying to compare 4 to the power root 2 with another number. So 2/3 is going to be helpful if I use it with the base 4. So 4 to the power square root of 2/3 is going to be greater than 4 to the power 4/5. You agree? Because the exponents, square root of 2/3 is the larger exponent. So when I use it with a base of 4, 4 is greater than 1. This is going to be true. That's interesting. Well, it is interesting if you realize, hey, 4 to the power 4 is 256, and 3 to the 5th power is 243, and 4 to the 4th is greater than 3 to the 5th. That is kind of interesting, but not very interesting enough unless I divide the exponents by 5, because I do need, notice that, I do need 4 to the power 4/5, and it's going to come from here. You get the idea? So let's go ahead and raise both sides to the power 1/5. It's equivalent to taking the 5th root of both sides, which is valid, right? These are positive numbers. Everything looks good. Even if they were not positive, this would be valid. Anyways, this gives us 4 to the power 4/5 greater than 3. Awesome. And I do have that right here. How does that help? Let's see. 4 to the power square root of 2/3 is greater than 4 to the power 4/5, which is greater than 3. Get rid of this number in the middle. We don't care about you anymore. Too bad. Now go ahead and compare these two numbers. 4 to the power square root of 2/3 is greater than 3. Now I can write this as 4 to the power square root of 2 over square root of 3 is greater than 3. Now let's go ahead. Isn't that tempting? Raise both sides to the power square root of 3. And let's see what that gives us. Surprise, surprise. Okay. So I'm going to go ahead and get rid of the denominator here by raising both sides to the power square root of 3, which is again valid. And now the square root of 3 is going to cancel out from power of a power property. What a name. And this is going to give us 4 to the power square root of 2 is greater than 3 to the power square root of 3. A lot of times people say, hey, when the base is smaller, it's usually the larger number. But in this case, that's not the case. Okay, now let's go ahead and take a look at the numerical values, and then after showing you the numerical values, I'm going to go ahead and talk about a functional approach. Well, it's not an approach, but I'm just going to show you something. How about that? Okay, so no promises like I'm going to show you something significant, but just show you a graph. How about that? Okay, so this is approximately 7.10299 dot dot dot, and this guy over here is approximately 6.70499 and dot dot. This is kind of interesting because after the fifth digit after the decimal, everything, so the numbers both end in 99, and then obviously there's infinitely many number of digits, but that's kind of interesting that they have the same two digits in the same place. Anyways, now here's the million-dollar question. Can we functionize this? And what is that supposed to mean? I came up with a new word. Hopefully that's going to go into the dictionary if it didn't already. Can we functionize this? So can we look at a function? So when I'm thinking about 4 to the power root 2 and 3 to the power root 3, this is what I thought about first. Okay, I want to express this as a function so that when I replace the x with different values, I get both of these outputs. Those are my outputs, those are the y values. So what is the f of x value, right? Well, could I do the following? How about f of x equals, looking at 4 to the power root 2, it looks like I could probably use x to the power square root of, let's see, x minus 2 maybe, because 4 minus 2 is 2. But when I apply it to the other number like 3, it doesn't work. Okay, I'm going to try another function. Again, allow me to use f of x because this one already, I got rid of it. How about using x to the power square root of x? That would work for 3, but that wouldn't work for the base 4. So I couldn't find that, nice function, but actually I did after considering this for a few seconds or minutes maybe. How about considering this function, x to the power square root of 6 minus x? That's the trick. I'm like, finally, yay, 4 plus 2 is 6 and 3 plus 3 is 6, and x plus 6 minus x is also 6. Really? Yes, because x cancels out. Awesome. So that's the relationship I'm looking for, and the derivative of this function is messy. Trust me on that. That's why we're just going to take a look at the graph. This is by no means a solution. It's not like an approach or a method. I just wanted to share with you, like, okay, we can kind of functionize things. Like we can turn, what's it called? We can turn a numerical value into a function. And then notice that here, if I replace x with 3, f of 3 is going to be 3 to the power square root of 3. And f of 4 is going to be 4 to the power square root of 2. Let's go ahead and take a look at the graph. Here's what the graph looks like. Yay, that is my function. And look at the values. This is 3. This is 3 to the power root 3. And this is 4 to the power root 2. As you can see, this is a 4. That's a 3. That's my function. Those are the y values. And clearly, 4 to the power root 2 is greater. Obviously, that's not a solution. It's just a graph. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.